Unit 4, Risk and Return, Lecture 2, Investment Risk. Now, attached to every investment is risk. So whenever you make an investment decision, you have to consider the return you're going to generate on that asset, and you have to look at the risk that comes along with that return. When looking at investment risk, we usually use variance and standard deviation. And for a single asset, the variance does involve the probability of the state again, and we multiply it this time by the difference between the return on that state and the expected return, and we sum these over all the different states. Your standard deviation is just the square root of your variance, and we use the standard deviation when we talk about investment risk because it's in the same units as the original information. So if we're looking at returns and they are in percentages, our standard deviation is in percentages as well. Now we're going to follow through with the same example that we used before when we calculated the expected return. The information is exactly the same and the expected return is 9.76%. And now we're going to calculate investment risk or variance and standard deviation. Using the formulae that we've already introduced for variance and standard deviation in the previous slide, we calculate the variance for this asset to be 0.038. Now, so that we can understand what the risk is for our asset, we actually use standard deviation, which is the square root of the variance, and in our case it turns out to be 0.1949, which is 19.49%. And since returns are generated or given to us in percentage form, we now have a risk measure in the same units. And really, how you interpret your standard deviation, you want your standard deviation to be as small as possible, because your variance to standard deviation gives you an indication of how widely spread around the mean all your returns are, and you want that to be as small as possible. You want your returns to be tightly compacted around your mean for this investment. When we're looking at returns for assets, so when we're looking at how an asset is performed or what we expect an asset to do in the future, we look at different types of returns. The arithmetic average of a rate of return is an average, it's straight average. In other words, we add up all the returns and we divide by the number of returns that we have. And it is each observation or each return in our set of data is equally weighted or equally likely. We use the arithmetic average in order to forecast returns, because we don't know what they're going to do in the future. We just take whatever returns we have, we find its average, and we use that as our estimate for how the asset will perform in the future. We're going to look now at a simple example on how to calculate the arithmetic average. You have invested 1,000 Rand in a money market account that earns 20% in year 1, 6% in year 2, and 1% in year 3. You want to know what the arithmetic average is going to be. Looking at the solution below, we see it's as straightforward as taking the 20% plus 6% plus the 1%, dividing it by the 3 years that you've invested the money in, and you end up with an average of 9% per annum. And the way you interpret this is looking forward. If you continue to invest your money in the money market account, you can expect to earn 9% per annum on average. When we want to understand how assets or portfolios or investments have performed in the past, so they have generated returns, now we want to look at how they performed on average on an annual basis. We use the geometric average. And even here, each past return receives an equal weight. But we calculate a geometric average. In other words, we look at a compounded annual growth rate by looking at the product of all the returns and taking the geometric average to get to our investment return. Using the same example as before, we're now going to calculate your geometric average. So we're going to look at how your investment has performed over the past 3 years. Again, you invested 1,000 Rand in a money market account that earns 20% in year 1, 6% in year 2, and 1% in year 3. What is your geometric average? Well, it turns out to be 8.71%. So, on average, your fund or your money earned 8.71%. This is only about past performance. You cannot make any assumptions about using this information about what's going to happen going forward. When we are trying to calculate expected returns and risk for investments on which we will base investment decisions, we like to know what the underlying distribution of those returns is. And we would like that distribution normally to be the normal distribution, because the normal distribution is a very nice symmetric distribution. It's bell-shaped. We know its parameters. We understand what it's doing. Also, standard deviation is a good measure of risks when returns are symmetric. If returns are symmetric, then portfolio returns will also be as well. So we will have a better understanding. And if the underlying distribution is normal, then future scenarios can be estimated using only the mean and standard deviation. But unfortunately, this is not always the case. Investment returns are not often normally distributed. Excess returns. For us, this makes things difficult because the standard deviation, which is a fairly easily understood measure for risk, is no longer a complete measure of risk. The Sharpe ratio, which relies on standard deviation as the measure of risk, is no longer a complete measure of portfolio performance. And now we need to start looking at not a symmetric distribution, but we need to start looking at skewness, because the distribution can be skewed either to the right or to the left, and kurtosis. Kurtosis is peakness. In other words, how high is the peak on the distribution? So is it peaked and clustered around the mean, or is it flat and skewed either to one side or the other with fat tails? This is a plot of the normal distribution. It is possible that you might have come across it, but if you haven't, here it is. The next two slides give us an indication of what distributions look like that are normal and skewed, or normal with fat tails. Now this has a significant impact obviously on the risk of your investment. If it's skewed to the left, not good, because that means there's more likelihood of making losses. So the nature of the distribution impacts on the risk measures we can use and the riskiness of our investment.